Silence. Order. I have returned to the demo scene, to all those people who were so mean. I will destroy everything they got. Make me your leader, vote for evil bot.
Seminar of Revision 2016. My name is cyrusdreams. I'm an electrical engineer and part of the organizers here, and I don't know how to code. So when there was the question on our mailing list, could somebody please explain what all the cables are that we are using here? I said, well, yes, I can do that. That's something I know some stuff about. I'm quite surprised that we have so many people here in the room. So we half filled the room with a seminar about something uninteresting as this, and I tried to make this presentation about cables interesting. So let's start. What can you expect from the presentation? So I will talk about a little bit about history of each of the connectors that we come across and history about cabling in general. We have the four main types of cables we use. We have power, audio, lightning. No, not lightning, lighting. Lightning would be bad. And video cables and data, basically. But data is the shortest of all of those slides. So wiring started when the first power distribution was starting to happen, and telegraph. So what we actually see in the picture over there is New York City in 1888. Everything was full of transmissions that were telegraph lines, because it's a point-to-point connection, a telegraph line, so there's no bus, so everybody who wanted to have a telegraph connection needed a cable. So it looks a bit like revision today. And connectors, I think they were not invented yet. What they basically did is, here you have this little screw connectors, and you just took your wire, put it there, and tightened the screw, and that was your connection. So connectors is not such a new, such an old thing. And 1893, on the top right, you see there actually were no plugs in the wall to put in your stuff, your heating elements and stuff like that. You had this screw-in type of connector that you screwed into a lamp fixture, because what first was distributed was light and not power for electrical appliances. So that was the first type of connector, just screwing in the Edison socket. And 1925, the Schuko connector, which is used all throughout Europe, all the blue stuff in Europe is a Schuko connector. Anybody here who is from not from a blue country? Oh, there are some of you here from, okay. So I will explain a little bit what is Schuko. Schuko means Schutzkontakt. It's a protective contact. And the Schuko connector out here and here, so there's little tabs on the outside. This is grounded. And it's designed in a way that if you plug it into the wall, that's the wall connector down there, you will never see the electric conducting two connectors before the sleeve goes into the plastic. So you never can touch the live stuff. It's also the reason why on this Euro plug, which fits nearly everywhere in Europe, has this plastic and only the tip is metal. The metal tip will be inside your connector before it is actually touching the mains voltage. And the Schuko connector is quite, it's used 1,000 times here. And it is compatible to several other connectors. We have this contour plug, which is not earthed, so it's only for smaller appliances which are shielded outside. And this CE77 multi-purpose plug, which has this little hole here. It is compatible to the French type of connector, the ones that are used in the red countries. And inside this room, actually, we use one French cable, and this is fully compatible. The earth is there, the mains is there, everything works. There was a question? The Belgian service, yeah, running also on this type of plug. By the way, you are allowed to put your question if you have them. There's no question answer session in the end. Well, a little bit of it. I try to repeat your question so that everybody on the recording also can hear that. So just go on with your questions. I try to answer them as good as I can. One thing to note for people that come from the British Islands and everywhere where they have connectors that cannot be plugged in reverse, that includes France. In Germany, this connector, you can plug it in both ways. If you have a lamp fixture, don't unscrew your bulb when the connector is inside the wall, because the Edison screw on the outside could get live. It's a 50-50 chance if it's live on the outside or it's live on the center pin. So our lamp fixtures in all the blue countries are designed in a way that the plastic is reaching far high on the bulb so that this doesn't happen. But if you bring your own stuff from outside to the blue countries, just make sure that neutral and phase might be somewhere else. But we need more power at the revision. So, such a Schuko connector can just deliver 16 amps and one phase. So we have to step up a little bit. And there's this CEE type connector. The complete name is IEC 6309, and there are several of them. There's one on this wall that's a 16 amp. Then you go over this one here, 16 amp. You can have in the distribution boxes, it goes up to 32 amps. And so that you can see how large they actually get. This is the 64 amp 3-phase CE connector, and on this side, actually is an adapter. That's the 125 amp CE 3-phase connector. And yeah, this cable, 1.5 or 2 kilos. So longer pieces of wire, you don't coil them up. So you put them up in an figure 8 in a big box. So there's no spool for that because they are too huge. And yeah, this is far spread use. I think they also use that in the US, some type or other. There are things with 4 pins. If you don't need a neutral one, that is, if you only connect a motor on it, then you have one with only 4 pins. One is earth, you have no neutral, and you have 3 phases. I will not explain how alternating current 3-phase will work here for different speech. What I also want to say is there's some center pin. If you look inside the connector, this center hole, that's an interesting little hole, technically, because this one is shorter than all the other pins. And if you have huge loads, you must not plug or unplug them while there is power on it. Otherwise, you would make a big spark. And this thing is last made, first break. So if you plug in the connector, this little tab will be the last one that plugs in, and you can have some circuitry that then activates your big load. And it will be deactivated if you start unplugging, because this little pin in the middle will disconnect at first. And we have even more different power connectors. We have these Harting connectors. And this is used if you have a lot of phases that you control by dimmers. So all these power cans that can be dimmed up or down. So all of these pins might have a connection to a power can. And you will find those on the flying truss above the main stage up there. There's the Harting box stuff that we have. This is for controlling light fixtures. Even more power connectors. There is for audio and video devices, more and more you will see these Neutrik connectors. Neutrik is the company that manufactures them, and they come from this tiny little blue spot besides of Switzerland, which is Liechtenstein. Yeah, down there. And you thought Switzerland was small. Yeah, well, take a look at Liechtenstein. But they are everywhere. Neutrik, we will see them several times in this presentation. And the thing for this Neutrik power connector, the blue one, is you shouldn't unplug or plug them under load. So if there's voltage on the cable or if the lamp is already on, this thing has no breaking capacity. It's not like a Schuko connector. It will make sparks inside and will damage the connector over time. And for replacement of really Schuko, then there's the PowerCon True one. This one really acts like a normal household plug that you have. It's bigger than the blue one, the black and yellow one. So that's all for power cables at the moment. So what's quite easy. Let's go to audio cables. And let's start with the oldest one that's still in use. So we have this phone connector, you know that, 3.5 millimeters on everybody's smartphone. The original one is 6 by 3.5 millimeters. It's a 1/4 inch jack. And it has a lot of names. You call that phone connector, phone jack, audio jack, jack plug. Then what you will see in rigging inside here, if you build up or tear down our fair here, is the designation TRS. It just stands for tip ring sleeve, or TS, tip sleeve. And I will show you on the next page what this actually means technically. They were first used 1876 and are still in use today on brand new equipment. This connector is still used. You see a switching board. It comes from telephone switching boards. One picture above that is 1895 in Montreal. They used this connector. So the girl at the phone line, when you didn't have the dial plates, was answering your phone and asked you whom to want to connect, and then put this phone connector to the correct line to distribute you. And this was still in use until 75, you see down there, in smaller switchboards that wouldn't afford the automatic switching that we have today. Still in use 75 for this purpose, and still in use today for audio equipment. So the phone connector is used for the tip sleeve. You see it's only the tip and the sleeve. It's two connectors, two signals here. The single channel audio signal, and the sleeve is ground. Most of the time sleeve is ground. And then there is, you find this on brand new electric guitars. That's the standard connector your electric guitar will plug in. And also modern keyboards still come equipped with TS connection. Or you can have this as an effects chain, so it's two audio signals that one might be send and return and reference to ground on the sleeve, or it might be the stereo signal that you have on your headphone plug. And interestingly, the professional headphones still use the 1/4 inch type, so it's the thicker one, and it's a stereo signal, left, right, ground. And what you additionally can use, and that's something specific to audio installations, is balanced audio. So you send one signal, one audio signal. One is in phase, and on the ring, the tip is in phase, the ring is the inverse signal, and the sleeve will be ground. And with this, you can also supply power to microphones that have a built-in amplifier. And you do this by you combine those two signals. You give here the phantom power, which is up to 48 volts, sorry. And ground is the return for both the audio and the phantom power. Now, let's get a bit technical, more in detail. Why do we do balanced audio? Well, you have this audio line. This is the balanced audio line. And you have noise from the outside. Maybe someone switches on a lamp beside your cable, where your microphone is connected. You normally would hear pluk, the sound there. This noise will be added to both the left and right channel in the same direction, because the electromagnetic wave propagates through your cable. It will be a spike in both the same directions. But your audio signal is one times in the plus direction and the minus direction. And in the receiver, so in our mixing console, for example, there's a subtraction happening here. And if you subtract those two signals, the amplitude will just be double, and the noise will be cancelled out. So at the receiving side, the impact of those noises will be minimized. But having this and at the same time the old style for the guitar might be a problem if you have complex installations and you don't know what you're doing. If you use a TRS connector, tip ring sleeve, and you have the phantom power on, and you plug that one into a guitar, you risk damaging the active amp that's in there. And it really happened to me 2 times. We had a setup where we just didn't have the proper adapters. You normally use a DI box, what's called a DI box. If anyone comes to you with an electric guitar and wants to be plugged in your mixer, normally you put them a DI box in between because it prevents that you have here 48 volts, yeah, and you have the ground reference, and this is an example circuit. That's just the amplifier, and it's the output. You will load 84 volts on 48 volts on the output of the amplifier. In this case, there's a capacitor. It's not that bad, but at the same time, you have on this line 48 volts plus your normally 9 volts for your amplifier, so you have over 50 volts supplying your amplifier in your guitar, which normally runs at 9 volts. So you can imagine if it's not hugely robustly designed, it might damage your guitar. So that's something to remember with phone plugs, TRS, and phantom power. And the phone plugs, well, they unplug quite easily if you pull on them, and then there's this confusion with balanced and unbalanced and stereo. So what most of the time is used for audio connections from one point to another is we use XLR connectors. XLR is what I have here. You have the size, you can see it. That's an XLR connector, male, female. And well, he's asleep. The female one is always the one that has the holes. And the male one is where the electrical conductive pins are pins. So make up your mind with this, and you always know. It's for each connector true. The male one always has the pin, the female one has the hole. Hence the name. So you don't look on the shell, you look on the electrical connector inside. So actually this one was originally called Canon plug because Canon designed that in 1950. But an XLR was just the order number that you filled out on your paper when you wanted to order some of those connectors, and soon after that everybody started calling this the XLR connector. And everybody says Canon connector today. And there are several different ones, the 3-pin, 4-pin, 5-pin variants of it. And for audio signals, the 3-pin balanced one is normally used. You have the ground, and you have a ground on one, you have positive, negative polarity, and positive is sometimes called hot and negative is sometimes called cold, just to have the language. And there are wired interfaces to tip and sleeve. You can do that just by wiring. Better use would be using an audio balun or a DI box to convert between those two. Because if you just wire it, there's half the signal that you normally expect, because we had this subtraction going on where the signal gets doubled. And if you only use an unbalanced signal, the signal is half at the receiving end. And we are now transitioning to digital audio, and nobody wanted to throw away the cables. So what we actually do is we have digital audio on these XLR lines. And this is the AES-3 standard, also called AES-EBU. Shouldn't be connected to audio inputs, obviously, because it is full-scale noise that you then put in. It's a digital signal. The pinout stays the same. You it's a reference to ground, and you have one wire. It's a serial line with a fixed baud rate somehow, and the protocol is more or less the same like SPDIF. It's almost identical. So it's a stereo PCM encoded audio. So one wire here will transport one stereo stream. If you need more channels, you need more cables for that. And default sample rate is 84, 48. Will I get this one time right today? Up to 24-bit. And up to 192 kilohertz is supported on such a cable with the AES-3 standard. And you can even have timestamps. Timestamps is very neat. If you have a video and parallel to that you have an audio recording, then you hook up a BNC line, a Coaxial line, we'll see that later, where the timestamps are exchanged, and you can record then the audio signal with the exact millisecond correct time frame, and it will just match in your post-processing software. Other uses of XLR. So we have 3-pin XLR, which normally carries audio, analog or digital. It's also used for DC power. On the mixing consoles, there's this gooseneck lamps. They sometimes are plugged in with a 3-pin XLR, sometimes with a 5-pin XLR. And there is professional cameras by ARRI or Panavision. They use this for supplying power to their cameras. We don't use that at Revision, hopefully. Then there's 3 pins El Cheapo DMX 512. It's non-standard. It's prohibited to use the 3 pins, but the cheap lighting equipment sometimes uses that because the connector is cheaper than the 5-pin ones that it's normally supposed to be used. And we don't use the El Cheapo variant for DMX. We have 3-pin XLRs in the past for speaker amplified audio with a lot of power behind that. That's not encouraged to use. We definitely do not use that because the worst thing that can happen if you have amplified audio and you plug that in your mixing console. 4 pins used for DC power on cameras. I don't think we have that. And the 5-pin for the lighting, we have this later on a slide what DMX 512 actually means. So it's interface. And now coming to the amplified output that goes to the speakers. In this room here, we use these Amphenol EP5 connectors. I didn't know them before Revision. They are XLR collectors on steroids. It's the same design, but the size is double. It's like the double size of an XLR connector. And this 5-pin connection, you transmit amplified audio to your speakers, and you can do something like B-amping. That means your tweeter and your bass speaker get supplied 2 separate amplified audio streams. You don't have a passive network inside a speaker. You have an active network before 2 sets of amplifiers and will amp the tweeter and the bass separately. You can do this with 1 cable then. And this EP5 connector, it has its benefits, it has its problems. It's slowly replaced by the speakON connector nowadays. And the speakON connector, and it's again Neutrik, we had them before for the PowerCon. The speakON connector has 4 to 8 pins inside. The 4-pin version, that's the one that you almost everywhere can see on smaller scale public audience amplifier stuff. And you can do also B-amping with this because you have no the 5th pin is not really used for the audio signal. It's some data signal that they use for the EP5. So you have 2 pins for tweeter, 2 pins for bass if you need that, or you only use one of the pairs inside your cable. And at Revision, we use the speakON connectors with an 8-pole variant, which has even more flexibility, more audio signals amplified audio signals being routed through this connector. And the speakON connector has several advantages actually. It is made out of plastic. You normally would say that's bad in compared to the XLR or EP5, which is made of an aluminium. But the aluminium, if you squeeze that, it stays in that squeezed shape. You can never plug in anything. Yeah? And if the plastic is more flexible, you step on that, it maybe changes its size a little bit, and if you go away from that, it snaps back into place. So in practical use, the plastic thing, speakON, is more robust, more reliable than the XLR or the EP5. And it's the EP5 especially. And it has a neat rotating locking mechanism. So if the locking tab is not straight, then it's not correctly plugged in. You plug that in, rotate it clockwise, and it makes a snap that is audible, even if it's quiet, or you can feel that it stays in place. So it's more foolproof. And one of those connectors can have 30 amps RMS on each of its pins. We have multi-core cables. That's a nuisance that we had. That's an old school multi-core cable. That's all those very tiny coaxial cables going to a huge number of XLR connectors, and you have this stage box where you plug all the microphones in that you have on stage. Problem is, they break easily, and they are very expensive to replace or to repair because there's so many cables inside there. Now audio over Ethernet is taking over this job. So you have on stage, you have this analog to digital converter. In this case, that's a ROCnet. And you have a ROCnet Ethernet interface. It is separated from the normal LAN. You don't mix those. That's a dedicated LAN. And in your mixing console, you have an interface where the digital audio gets fed input into your digital mixing. Or you can have a converter that mixes it, converts it back to analog audio and distributes it inside your mixing console. One downside of this is that the AD conversion and digital transmission will add latency. And that's also the reason why it is a dedicated LAN. Those protocol extensions that they use, they try to minimize the latency so that you don't hear a lag between what is happening on stage and what is being fed into your mixer. And for the Ethernet connection, you have this, you know, the RJ45, which is originally called, yeah, we will talk about that later. It is too fragile, you know that. The locking tab always breaks off. And then there is, again, Neutrik and Liechtenstein, so they are omnipotent in audio and rigging stuff. There are conversion kits for existing cables. Step number B states that you rip off the locking tab. That's step number B in this mounting guide. Because they are locking on the shell that looks exactly like an XLR. On the outside it's an XLR and there's a locking tab inside, which then neatly locks into place. Yeah. And replaces this plastic crap. And then there's some bunch of adapters and stuff that run around here in revision in dozens. So we have this RCA connector, which stands for Radio Corporation of America. They invented that. Or Cinch, as we call that. And there's actually a company called Cinch. Cinch Connectors even, they make connectors, but they never stated that they invented the name Cinch. They always say, we don't know why it is called Cinch, so I don't know. It's still popular among DJs because the Technics turntables, they have a Cinch output. This is the phono output. That's the reason why it's also called phono connector, which is confusing because the jack was also called phone connector. Phone and phono, it's a bit, you can mix that up. There's DIN connectors. Maybe we have that at the old school compo recording, I don't know, but nowhere else it is used. We have FireWire USB. This one was used last year to get the digital audio inside our recording. So we had this FireWire station where we streamed everything then onto the USB hard drive. So we might use this. And then there's crap like Toslink. That's cheap optical cable we don't use because we have no devices that use that. Then there's the BNC connector with coaxial cable for MADI. We don't have MADI at the revision, but it's a different approach of digital audio transfer, not Ethernet, but they use different cables. We don't have them here. And we come back to the lighting control. So up there you will see the 5-pin XLR connector, which is used for the digital multiplex, as it's called, DMX 512. Is connected to equipment that can dim your lights, that can move the lasers. You can transmit a lot of stuff, control data to light fixtures. And you have a big mixing console that's only purpose is mixing light effects. So we have this at revision. And the nice thing with the 5-pin variant is you cannot mix them with the normal audio XLR stuff, so you don't get confused. Is this audio? Is this light? So the light is always 5-pin, audio is always 3-pin, that's easy. But the connectors are a bit more expensive because the light is not that far spread. So you don't have that many light things in cheap way than you have audio. And the digital multiplex, it uses a daisy chain topology, so you can route that from one device to another device to another device. It follows the RS485 standard, more or less, for the UpDis. And from standard point of view, you could make a chain link that's over 1 kilometer long. In practice, you won't reach the kilometer, you don't do that, but it's quite robust what they do there. And because the length is this high and you need to cope with reflections on both sides of your wire, what you normally do is to terminate the end nodes, the far outer end nodes, with 120 ohm, because this is roughly what a twisted pair inside such a cable has as an impedance. And the makes sense asynchronous serial database, 250 kilobaud. Let's go to video cables and connectors. Well, video signals, they are much more have much more bandwidth than audio signals. So you cannot just use some parallel wires that you use for your speakers at home, because the least favorable video standard that there is the VHS composite. It has already 3 megahertz of bandwidth, and everything else is above that. It goes up to 6 megahertz for SVHS, which is in analog terms a quite nice video signal. And so you need coaxial cables for that. Coaxial cables have less losses, better impedance control, and I will show you what is behind those numbers. You have 50 ohms BNC coaxial cable, you have 75 ohm coaxial cable. Why do you have that? And you have in consumer equipment a lot of those RCA connectors also for video, because they can have a few megahertz running over them. The problem later on is that you cannot connect proper low loss coaxial cable on this. So in professional or more or less professional like revision types of installations, we convert that to digital as soon as possible and then run with a digital video signal. And coaxial cable, yeah, the idea is it was invented in 1880s, so this is quite an old style of cable. It means that you have a center conductor, you have an insulation around that, and you have a metallic shield which surrounding it circular completely. And this gives you some shielding from the outside, because normally on the outside you make your earth reference for your signal. And you have a controlled impedance, which means that you have a low attenuation in your cable. It just can stretch farther on the cable then, because the attenuation is lower. And they tried that out in Bell Labs 1930s. The lowest attenuation that you have is 77 ohm if you use air as an insulator. And 73 ohms was, interestingly, it was very famous back then, because it matches very good to the receiving antenna of an AM radio. So you don't have circuits in between, you just have your dipole and you can plug in this cable and everything's matched. If the impedance does not match, you get reflections on each point where the impedance changes. And this makes losses, and it also makes false signals. So you have echoes going on. And with a high bandwidth signal, those echoes will start to get annoying, because your signal will have ghost images and stuff like that. So you try to have a controlled one impedance through all the system. But the maximum power handling for such a cable is at 30 ohms and not at 75 ohms or 77 ohms, because at one point you get sparks from the outer conductor to the center conductor, and high voltage breakdown due to heating of the cables, they will get hot. So the 50 ohm is a compromise between the 75 and the 30 ohms. And the situation today is, if you have a low power antenna that's only receiving or only using a few milliwatts, and video systems, they focus on low loss, long cable length, so they use 75 ohms. Everybody else uses 50 ohms. That is a little bit of a problem, because the cables are different and the connectors are different. So for video here, we connect, a component video was connected with 75 ohm coaxial cable with a BNC connector. What does BNC stand for? It's Bayonet Neil Conselman. Yeah, there was a question? No. Bayonet Nut Connector, Bayonet Navy Connector, British Naval Connector. Nobody can agree on what BNC really means. The only thing we know is that those two guys, Mr. Neil and Mr. Conselman, were responsible for developing this connector. The first connector is the C connector. This is Conselman's connector that he thought of in 1940s, which is waterproof, and they improved that by reducing the size, and they have now the BNC connector, where Neil supported some ideas, which is not waterproof anymore, but smaller, more convenient for inside cabling. And they can transmit signals up to today, up to 4 gigahertz or even higher if it's very good made. If you have a 75 ohm coaxial cable, you need a 75 ohm connector. The trick is there are 2 connectors there. You have a 50 ohm variant, and you see that with a plastic inside. This will reduce the impedance down to 50 ohms and help you with power transfer. And you have the 75 ohms variant. Luckily, those 2 can mate without damaging. And if you look at those cables that we have, the SDI cables, most of the time they equip the 50 ohm connectors because the 3, 4, 5, maybe 10 megahertz is not 4 gigahertz where it really is a problem. So they just ignore that and use the cheaper connector because the 50 ohm connector is the one that is produced in huge amounts. The 75 ohm is less so produced. And additionally, maybe it's a bit more robust because of the plastic inside. You cannot break off these little contacts there. And for video also, there was this transition to digital. And they did the same thing as with audio. They reused the cables. So the SDI, serial digital interface, it uses 75 ohm coaxial cable that we have running around here at Revision. And this can transfer 270 megabits up to 12 gigabits, which would translate to several gigahertz of bandwidth on the cable. And the HDTV data rate actually is 1.5 gigabit per second. And that SDI interface is transmitting uncompressed 20-bit component information on this SDI cable. So the bandwidth is used up. So it's not that you can have more than 1 video stream on such an SDI cable. Plus it runs embedded audio up to 16 channels, 4824, like the one on the AES EBU. And it's actually more or less easily converted. And the audio, if you compare that, is much lower bandwidth. It doesn't really matter. And we have other AV interfaces. We have a lot of professionally packaged HDMI crap. HDMI is used on all the consumer video equipment today. And we convert it as soon as we can to SDI or something other, any other digital format with those boxes, and we never have enough of those boxes. The problem is the HDMI connector is inconvenient because it has no locking mechanism. It falls out of your professional equipment. There's no locking on it on the normal standard. It's not robust. It has huge amounts of tiny little connectors on it, and you plug it in this way, 3 degrees in the other way, 1 signal is missing. That's annoying. But it is widespread and cheap. That's the reason why every device has such an HDMI connector. And additionally, the HDMI cables, because there's so many electrical connections going on, it's a very stiff cable. And these big cameras we use on the main hall and also inside here, if you want to carry them around, this big stiff thing is blocking you down. So we need those on SDI with a coaxial cable, which is far more soft and pliable and not so heavy to carry around. And even more audio-video interfaces that are running around here. We have HD-based audio-video bridge and digital interface for video and audio. There are a lot of different standards that care about putting your audio and video signals onto alarm. What we use first time at Revision, we do not use the SDI connection to the main hall from here. The first time in Revision, we now use an Ethernet connection with one of those standards. I didn't get that in time, which one we actually used for that, to transfer our signal over a LAN to the main hall to be streamed to the outside. There's also IEEE 1394, aka Firewire or aka iLink. It was very popular during a certain time on video cameras. You did find that everywhere instead of before HDMI, but that's not used at Revision. And we have also VGA, DVI, DisplayPort. Well, we have displays, you know, we need to wire them up. We order a lot of those cables, and we have one here to connect my laptop to something that converts my VGA signal to digital and transports it down there. And data, we must not forget data. It's getting more and more important. We have the Ethernet physical layer can have 2 varieties here at Revision for Ethernet. That is copper and optical fiber. And we have this connector that everybody has. It's the 8PAC modular connector. That's the proper name for this thing. Everybody calls that RJ45, which basically means registered jack. And this normally would only apply to a telephone line. So the registration program which registered jack applies to is from the FCC in America, which you had to enter your phone to the registration legislation stuff, and they told you, oh well, yeah, you can sell this in the US. It is a proper equipment that you might connect to your wall outlet, and that's the registration. That's the reason why it's called RJ45. Normal name would be 8P8C modular connector, but that's bulky. And we have optical fibers here in revision. We have several benefits of that. You have ground separation, so you know this ground loop, mains hum, stuff like that. If you have an optical fiber in between, it's gone away because there's no electrical connections, only light running through the optical fiber. And you can have at the same time higher bandwidth or higher distance, because there's less damping inside such an optical fiber than there is in a twisted pair cable. We use two types of connectors. The older one is the subscriber connector, or square connector, or standard connector, or SC for short. And the one that is half the size of this is the LC, the lucent connector, little connector, local connector, whatever connector. So there's one sending and one receiving fiber in such a pair. And you can get them with only one fiber also. It's not mandatory that it is in pairs. Now we are already at a bonus program. I will ask for questions from the audience before I show you how to correctly wrap up your cables. No yeah, that's a question.
I have a question regarding to HDMI and SDI.
Yes.
I don't know how to ask this question, but HDMI seems really much straightforward to me. You know, just like plug it in and it just works.
Yeah.
And if you go to the SDI world, then this is just like a totally different world of cables. You know?
So the question is the difference between SDI and HDMI. You say it's much more straightforward to have an HDMI, you plug it in and it works, and SDI seems to be more confusing to you. Well, I would disagree. We have this video mixing console there. The SDI is just one cable and it's one connection. It's more likely to have a connection if you plug it in. That's one thing I would answer to that. And on this stuff we have there, the cameras and the TriCaster video mixing console that we use, we have less problems with the SDI connections. You plug them in and they work, and we have the opposite way with the HDMI. So it depends on your use case. I think for the consumer world, the HDMI is the much simpler variant because everything is handled there and they know about their video format. If you go to the video mixing consoles, HDMI starts to get annoying because of different reasons. Yeah. Additional question? Yes.
Cable length for HDMI and SDI.
Cable length for HDMI and SDI. So HDMI, you know, if you have, let's talk without in-between amplifiers. You have one meeting room, for example, then you have one length of HDMI which cannot go up to 4K, but it barely manages HD. That one ends up at 15 or 20 meters. The SDI cable length from here down to the main hall is, we used, how many meters did we use? I think 50 meters, no problem. The propagation on this cable is so good compared to the HDMI, and it's full HD that we transferred down there. And we can I think we can get 100 meters. Yeah. Yes?
What was the technical difference between the audio switch cables and similar looking cables for video?
The question was, what is the difference between the RCA audio and RCA video? From connector side, they are identical. The difference is for video you must use a coaxial cable, and they start getting controlled impedance. Even if the audio cables most of the time are also built coaxially. You have the inside wire, and outside there is strands that are ground for audio. But the audio cable manufacturer will have a hard time telling you which impedance they reach. But it's not that important because your frequency range ends at 100 kilohertz and doesn't go up to 3 megahertz. Connector-wise, the sizes are identical. So okay, back to the bonus stuff. So I have here a length of XLR cable, and I will show you a neat trick with that before I show you how I call that up. So if I throw this one, it will untangle automatically. And if you compare that to how you are used to winding up a cable, you have this cable, you're trying up to make a spool. Well, the first thing, the best way to wind up a cable is using a spool. That's the best thing. You have a spool, like inside your vacuum cleaner, you can roll it out or roll it in 3,000 times, it always works. But you don't have spools all the time. It would take much more space to have even this on a spool. So what you at home normally do is you wrap this and you wrap it again and you wrap it again. And if you feel that in your hand, you will see that you actually are doing a 180-degree turn with a cable and only in one direction. So this means this 180-degree turn is transferred down there. For short cables, you will not notice that because the end will start to rotate on your floor. So that's not a problem. But if we have here XLR cables 30 meters long, you will have a mess somewhere down there, and if you force that inside, your cable will start looking like a spiral cable on your phone. They will stay in this tangled place. It will be curly even if you untangle them. The proper way to do that is to have a counter motion for this. And you can do this in either style. And some people prefer to wind like this, some people prefer to wind like that. And the style is called over and under. You have one thing that goes down here, so this turns the cable in this direction. Now comes the under part. That's the new thing. You take this one and you go this way. Yeah? And you suggest that also with your hand, have this motion. So I have now one time turned it in this direction and another time turned it in the back direction. And I go over and under and over and under. And you're even as fast as if you do it normally with only one direction, over and under. You know, that's too short for that. And you have gained the ability to just throw that tangle-free somewhere. You can do it also the other way around. That would be over, and some people like to do it like this, under, and over, and under, and over, and under, and over, and under. That's the best way to wind up your cables. Thank you. Thank you. So what did we learn today? Nobody agrees on how connectors are actually called, and the actual acronyms, so nobody knows. Not all Ethernets that we have at revision are equal, so you cannot connect everything on each switch. It will break down revision. We use a lot of cables. If you notice down there, I had this running counter. You can do this in the recording later on. In total, we end up with 16 kilometers of cable length with a hole that is 70 meters long. I think we can wind that up several times around this hole, the total length that we have. And I want to thank you for listening to this presentation and wish you fun and good time at revision. Thank you.